After the hands-on task where the students can calculate stress by hand from the ECG outputs, we have a coding task which essentially does the same thing. It calculates stress and it also calculates thresholds and does data interpretation and visualization. And this is through a Python script. And depending on the level the students are at or how much they learn in school, whether they're familiar with Python or not, this is a simple, easy task for them to do. And it's again up to you how you decide to do it based on your experience, their experience, and whatever works best as a class. So it is a Python script and it's all written completely, so the students don't actually have to change anything within it. There is a task where they can edit some numbers so the graphs can show differently. That's the only thing they have to do, so there's no actual coding involved in this. Again, if you want to, or if you want to kind of challenge the students, you are free to take some sections out. There is a reference. The coding part of this task elaborates on the first task that the students do, where they calculate stress by hand from the ECG output. This is a Python script and it uses data from, it's an average data set taken from a paper online, but we're just considering this as one data set from a person. It measures their stress, their heart rate data over time, and we're going to interpret this and plot some graphs from this. So what this does, it calculates a stress value. And based on the stress values over time of this person, we can then see their threshold values. We can see what levels they are for high stress, no stress, and low stress. So once we find these threshold values, we can use these in the app we're going to create later on. So I'm just going to show you how to get up and running with this coding script. So all the scripts are on a GitHub. So the link for this is all in the information pack. So if you just search this GitHub, you should come to a medical device workshop channel. And there's three things in here. There is a text file which just has the raw Python code. So you can copy this into Spider or whatever Python interpreter you use. So you can run it all just straight away in a Python output. Or we also have a Jupyter notebook, which you can use either through Google Colab or on Jupyter itself. And there's a CSV file of the data here as well. So you have to have the data file in the same folder as whatever file you end up using, because the script pulls from that data. So you're free to either kind of copy the text or use the Jupyter notebook like this. So this is what it looks like. In the Jupyter notebook, it is separated into separate sections, so you can run each of these individually and kind of go through one by one and almost interpret and look at the data and look at the code, so the students can really understand what part each of the code is doing. So for example, the first part, we would just talk about how we are importing the certain libraries that we need to use, like pandas, numpy, and the plot figures. And then the second part, so we need to run that first, and then the second part is in uploading the data. So for example, if you wanted the students to get a bit more experience with coding, you could, for example, get rid of the CSV file here and have them just type that in, for example. So you run that, and then the third bit is plotting the graphs originally and plotting the raw data as it is. And then that should produce this plot here. And this plot is too much data, basically. So it goes from 0 to 350,000 data points, which is so many, and from this we can't really see much. Compared to the ECG output we saw earlier on paper, this is crazy, like it's too much data. So we need to then eliminate this, and we need to shorten the data points, shorten the windows between them, and bring this data to a point where we can actually interpret it and understand it. And this is also just a good conversation for the students to have. Like, this is real life data, this is real life stuff that researchers do. We often have so much data and we need to condense it and figure out what's the important part of it. So this is part of the process as well and part of the discussion. Step 4 calculates the RMSSD of the whole data set all at once without any interpretation or any cutting down of the data, and it provides a value of 55. But the thing is here, when we want to look actually into the data and interpret it and cut it down so it's actually easier to see, we get something like this, where actually we find that the stress is changing over time. Whereas the RMSSD is just giving one straight value, an average of 55. But when we cut the data down, we decrease the window size number, essentially stretching the x-axis, and we look on a closer scale, we can see that stress is changing over time for this person. And this is actually more informative and more what we want to see, and this is the kind of things that smartwatches would detect, is this stress change over time. So this is also the part now where we can change the windowing size. So essentially it's changing the data points. So each one of the window point, we kind of refer to it as windowing, but you can just call it the data points. So here it says we apply windowing and calculate the RMSSD for a shorter time period. So we're just changing the size of the x-axis essentially by doing so. And this is the bit the students can change. So you can get different interpretations of this graph. So at the minute, the window size we've reduced to 10,000. So we've gone from 350,000 to 0 to 35. So this has reduced it by 10,000. That's what that means. But you can do this for 1,000, 100 and different ones, so you can see how this changes and how the graphs change and how the data changes. So this is actually quite an interesting task that you can get the students to do, is to change that value and see. And essentially if you kind of get down to 10,000, this looks nice and clear, and we can see that here. So between 0 and kind of 19, we've got a low RMSSD value, and then it spikes up, and then it spikes up again. And this, because this is the RMSSD, this is the changing stress levels of this person over time essentially. So we know that a low RMSSD is high stress. So this person was really stressed, and then their stress started to decrease, and then it decreased again. So we can see then for this person what their threshold values would be just from interpreting this graph. But then if we go on to step 6, then we calculate the RMSSD for a window size of 10,000. Well, that says 1,000, but we've got 10,000 here. But again, it depends on what you want to do. We just picked 10,000. And then we can calculate the threshold value. So this prints out this graph here, which is the same as this graph, but we've just color coded it now so we can try and interpret it and see visually the boundaries and the threshold values. And then the final bit, step 7, calculates the values of the RMSSD and the threshold value. So this should then print out the threshold values for this person. So the high stress is anything below 51, low stress is anything between 51 and 56, and everything above 56 or 57 when rounding is no stress. So then these are the values that we'll use later on in the app. But this is just a little coding task to get them to understand how we can input data, large data sets, how we want to change and manipulate this, how we can do different graphs and plots and interpreting the data. And then we can improve that by visualization. So having this color coded is so much nicer than just interpreting the graph like this. So we can see clearly at what point this person went from high stress to medium stress to no stress. So this is what the coding task is all about. So like I say, you can do it on Jupyter or Google Colab and things, or you can copy and paste it all into just a Python, like a spider, and do this task. So yeah, you can decide which aspects the students change, whether you want to do more, but we would just recommend getting them to change the window size and seeing how this changes the graph output. And hopefully then coming to a conclusion that around 10,000 looks pretty good, and we can see nice and clearly how the stress of this person changes over time. So I hope this makes sense for you. If there's any questions, please do get in touch if it's not clear, and then you'll use the data and these values here that the students have got for the next section in the app section. So make sure they write down these values as well.